The complex numbers z and w are z is -1 plus root 3i, and w is 2 cis theta. Express z in polar form. So that's going to be -1 plus root 3i. So this is 1, this is root 3. That means that this angle would be pi by 3, and the length of the hypotenuse here would be root 3 squared, which is 3, plus 1 squared, which is 4, square rooted, which means that it's 2. And of course, the pi by 3 angle came from the inverse tangent of root 3 over 1, a standard angle that you should know. Therefore, z is equal to 2 cis. Now, if that angle is pi by 3, remember the argument is actually measured from the positive real axis. So this would be the angle. It would be 2 pi by 3. Express ZW in polar form with theta between -pi and pi. Well, we know that we multiply the moduli, so that's going to be 2 and 2, so that's going to be 4. And we add the arguments, so that's going to be theta plus 2 pi by 3. But we were told in the question that theta is obtuse. So if we have theta here, and then we add 2 pi by 3, which is also obtuse, it's certainly not going to be between 0 and pi. It's going to be more than pi. So we need to rearrange so that we get this angle between -pi and 0. So this angle here was, of course, 2 pi by 3. So if we measure instead from the theta in this direction, this angle would be 4 pi by 3. And so what we get is that this is 4 cis theta take away 4 pi by 3. And that will now be between -pi and pi. We want z cubed in Cartesian form. So it's going to be cube the modulus and multiply the argument by 3, which is 8 cis 2 pi, which is better known just as 8. Think about where that is. 8 cis 2 pi is just here. Finally, we want to find the modulus and the argument of z minus 2. So let's draw a diagram to help us with that. So if we think about z at -1 plus root 3i, which is here, or if you like, it's at 2, with this angle being, of course, 2 pi by 3. Z minus 2 would go over here, and of course this line is horizontal because we're taking away 2, which is just a real number. Now this has become a fairly standard sort of question in recent times, in that what we do is we form ourselves a rhombus, and then we think about the diagonal here, which of course will bisect the angle. In other words, the little angle in here would be pi by 6, since the whole angle here is pi by 3. So the argument is fairly straightforward. So the arg of z minus 2 is going to be 2 pi by 3, add the pi by 6, which is 5 pi by 6. Now, if this angle is pi by 6, or in degrees 30 degrees, then this one is also 30 degrees, leaving this angle here as 120 degrees. So for the modulus, we're after the length of the diagonal. And we could do that using the cosine rule. So let's just call this x. So x squared is going to be 2 squared plus 2 squared minus 2 times 2 times 2 times the cosine of 2 pi by 3, 120 degrees. So that's going to be 4 plus 4, take away 8 cos 2 pi by 3, which is 8, take away 8 times, and the cosine of 2 pi by 3, again a standard angle, you should know this, is -1/2. And so this ends up being 8 plus 4, which is 12. And therefore the x, or if you like, the modulus of z minus 2 is going to be the square root of 12, which at this level you really should say is root 4, root 3, and then is 2 root 3.